Right, so hello. Sorry for that.
Hello, sir. Okay.
Sorry for that. I thought we still have like 5 minutes left, but I wasn't able to find it already the remaining time. So let's see. So I guess we can continue now. So the others who are not here yet will just catch up to us. Anyway, once the abstraction, I guess the best way in abstraction, best way to explain this one is by using a diagram. It seems that I cannot find one. Anyway, so when we say abstraction, so it is dealing one part to another part of their module, wherein let's see, I've clicked or I've opened the pizza ordering system itself. So in here, upon opening this one, of course, it will undergo to a certain process. Okay. So process to show the interface for the order, interface for the reserve, interface for the whatever feature is this one. So in here, we have this abstraction wherein, what is happening before it will show this module writer or this interface writer is called as abstraction. Okay. So for example, the process that will happen if I open this one, it will read via ones and zeros because that's how our computer reads the data. Okay, and then will be translated into a picture or a text, etc., etc. Now we don't care what's happening on that process anymore. Okay, what we only care is what will be the output after opening this application. Okay, well, that is the way that is one way for me to explain the word abstraction. Or I guess I can use another example. Now let us use riding a or driving a car or driving a motorcycle. Okay, now as a driver, you only care about your throttle, your well, if it's automatic, it's just the throttle and then how you balance the motorcycle, right? Okay, so that is the only that you need to worry about. Now, when the abstraction, so go deeper on the process wherein what's happening if you uh, pull the throttle. Okay, so you don't really care anymore what's happening on the machine. Okay, what if you uh, pull the brake? You don't really care what's happening or how it's stopping your tire from moving. Okay, what you only care is it must stop right away after hitting that brake, or it must go right away after hitting that or after pulling the um, throttle. Okay, so those are the uh, examples that I can think of in defining or describing the word abstraction. So in here we have functional abstraction. So we don't really care how does that function really break. What we care about is once I did that function, it must do its job. Okay, so that is why it mentioned here that the details of algorithm to accomplish the functions are not visible to the user of the function. So what the user care about is it must be able to work properly, or that function must work as it should be. Okay. So another one is data abstraction. So let's see, fetching a data and then sending that data to this another module. So you don't really care how that or how does that module fetch the data and then send the data to another module or to this another program. Okay, so what we only care about is, it must be able to send this data from this point up to this point. Okay, so again, data abstractions forms the basis. Oops, my bad. Here, details of the data elements are again not visible to the user's data. Okay, so it could be a function or a functional abstraction, or it could be a data abstraction. Okay, so are we clear so far when we say abstraction?
Yes, sir.
Yes, sir.
So I would say that this is, this part is more on the developer side. Okay, so they're only dealing with the internal details of the implementation, but for the user, it's not that really important. Okay. Anyway, next one is modularity. So modularity specifies the division of software into separate modules, which are differently named and addressed and are integrated later on into being completely functional software. So this one is all similar with the problem of partitioning. It's just that uh, in here, we call that one smaller problem because it's a problem. But what if it is a solution? Okay, so this one talks more about the, in a general sense. So you are dividing the module itself, so it could be a problem or solution, into smaller chunks. Okay, so it's also like partitioning, but not specifically a problem of partitioning. It's just that you're dividing this module into smaller modules. Okay, so here are some properties. Okay, if you're going to use a modular system, each module is well-defined system that can be used with other applications. Each module has a single specified objectives, and modules can be separately compiled and saved in the library. And modules should be easier to use than to build. Modules are simpler from outside than inside. Okay. So those are the properties that you must have if you're going to apply this modularity in your or while creating your project. So here are some advantages. Of course, there's a lot of advantages. So it is kind of similar with this one, but more on uh, in a general sense. Okay, so it allows large programs, so it could be a problem or solution, to be written by several different people, since you already divided it into smaller chunks. So it encourages the creation of commonly used themes to be placed in the library and used by other programs. So integration. It simplifies the overlay procedure of loading a large program into main storage. It provides more checkpoints to measure progress. It provides a framework for complete testing, more accessible to test. So it produces the well-designed and more readable program. Okay, so those are the advantages. However, of course, it also has some disadvantages, like for example, execution time maybe, but not certainly longer. So say from 2 second execution, it might become 3 seconds, since instead of dealing in just by just a one module, you need to run two module. Okay, so let's see, 2 second for this one, and then another second for this module. Okay, and then storage size perhaps, but is not certainly increased. So yeah, it will increase, but only a little. Okay, let's say maybe from 2 GB will become 2.1 gigabytes. So it will increase just a small amount of storage. Then compilation and loading time may be longer. Well, it's very obvious. Intermodule communication problems may be increased. Of course, that is always a problem if you're going to uh, separate your problem into smaller chunks. So how will you connect them as one or as a whole without a problem? Okay, that is always the issue if we have a smaller chunks of modules or smaller solution or problems in your system. Okay, and then of course more linkage required, runtime may be longer, more source lines must be written, and then more documentation has to be done. Okay, because instead of dealing one module, this problem, then you're now dealing with five smaller problems if you're going to do modularity or problem recognition. Okay. Then we also have here a modular design wherein we have functional independence, information hiding, and then okay, just those two. Now, when we see functional independence, so your module should or uh, can perform by itself only without the other module. Okay, so with that, it's a lot better if uh, you can come up with that uh, module wherein it can work as its own already without integrating or without getting the data from other module. Okay, so that is why this is where the cohesion and then coupling will be, takes into place if just in case that your module is not working or doesn't work as a standalone module. So later on, we'll discuss what is this cohesion and then what is this coupling. But for now, cohesion, it measures the relative function strength of the module. So the or the functionalities inside of that one module. But coupling is now measures the relative independence among the modules. So this one talks about the interconnection, okay, of these two module or three module, working as a uh, as a one. Okay? Then information hiding. So when we say information hiding, we're in where is the part where you are restricting. So I think I saw that terminology right here, but I cannot find it anymore. Anyway, so it's like you're restricting the other module in uh, getting or fetching or sending a data into that module. So with that, you'll be able to protect, here, you'll be able to protect your data from the others. Or in other words, the module should be specified that data included within the module is inaccessible. Okay, it's not restrict. So my apologies, not one, but it's inaccessible to other modules that do not need for such information. Now, if the other modules doesn't need that data, then do not declare it one as a global. Okay, just declare it one as a local. With that, you'll be able to protect your data from unnecessary access from the other module. Okay, so it might create a loophole, or it might create a what do you call this one? A part wherein they'll be able to enter to your system easily or easier. Okay, so that is always the case if you're always allowing the other modules or other functions or other features to accept, I mean to access everything. Okay, so as much as possible, apply information hiding. Okay. If it's not necessary to declare it one as a global, then do not declare it one as a global. Okay, just declare it one as local. Anyway, so are we clear under a modular design?
Yes, sir.
How many slides left? So we still have 16 slides left. So try to uh, make my way of discussing things faster since we don't have that much time anymore. Anyway, so let's move on now to the strategy design. So this one is very straightforward. We have the top-down approach and then the bottom-up approach. So top-down approach is, of course, you're going to start from the main problem itself, okay, into smaller functions, just like what we did a while ago right here in pizza ordering system. Okay, so in here you're like creating subcomponents of that one entirety, okay, or this one system into two, and then this sub components has another sub component, okay, which is now the level three. So this one is the top-down approach. So if we have top-down, we also have bottom-up approach, wherein of course you're going to start at the bottom. I mean at the at the bottom. It's just that this one now is at the top one. Okay, this is now your level one. So you're now dealing with the subcomponents first before the subcomponent, and then combine that as a one to come up with the one project or the entirety of your project. Okay, so it's just the opposite of each other. So top down from top to bottom, and then bottom up from bottom to top. Okay, so I hope we're clear with this one. And then coupling and cohesion. So in here, I guess the best way to describe this one. Okay, let's start with the uncouple. I guess this is very straightforward. When it's the uncouple, of course, each module can work, on its own. It's a standalone module, so it doesn't need the data from this module in order for this module to work. So this one is uncoupled, okay, no connection with other module. And then we also have loosely coupled. So when we say loosely, it's just some part of the, let's say, this module will be needed for this module to work. Okay, so it need to fetch the data first before it can process, or before this module can process on its own. Okay, so it's depending on another module. And then if we have loosely coupled, we also have highly coupled or tight coupled, if I'm mistaken. Where is that one? Loosely, tightly coupled. So sometimes they also call this one tightly coupled, which is not advisable. So this is one thing that you should avoid. Okay, having a tightly or highly coupled. But in some cases, we cannot really, avoid in by not having this one, especially if your system is really connected with each other. Wherein it's very dependent on each module. Wherein you need this data first before you can uh, process this module or enter this module, and so on and so forth. Okay, so before we only have two lines going in and then going out. Okay, so in here we now have two going in and then one going out, or vice versa, two going out or one going in. Okay, so this one is highly coupled. Okay, and this one is just loosely coupled, highly coupled, and then highly coupled. So this is a combination of highly coupled. But once there is uh, a highly coupled, even though there are some modules which is only using loosely coupled, this is already considered as a highly coupled. So yeah, okay. So I hope we're clear with this one. This one can work on its own. This one will not be able to work on its own if that data is not there yet. Okay, and then this is definitely not going to work if that data is not there yet. Okay, so it's really, or it's highly dependent on that module. Anyway, we have here the types of module coupling from worst to best. Okay, so best, of course, is no direct coupling, but it also has a lot of disadvantage. Okay, so instead of accommodating only a smaller chunk of storage, then if we have no direct coupling, like you declared everything in that module, you created everything in that module, so it might increase the storage that you will need to process that data or that specific module. Okay, because it has more lines of codes, it is longer to execute, it is longer to read, so it has a lot of disadvantages also. Okay, so I think for me, as a programmer, I'll go with maybe stamp coupling or control coupling. Okay, the middle one is the best one. So if there is a data that's already existing, then if we can use it one, then just try to integrate it one. Okay, so in other words, just apply object-oriented programming. Okay, OOP. Okay, as much as possible, try to reuse existing variables, try to reuse existing functions, try to reuse existing objects. Okay, but yeah, this is just in the sense of coupling. Of course, no couple, the better. Okay, and then the worst one is of course the content coupling, wherein it's like 90%, like you're getting everything already from that specific module. Okay, then that is not a good practice. Okay, well, in some cases, again, you cannot avoid this one. If it's really needed to do this kind of coupling, then why not? Okay, it's just that it's riskier, since if there is one error in this module, then the other module that doesn't have an error will also be affected, wherein of course it will uh, give you an error now also. Okay, with that, it's now harder to uh, called one troubleshoot. Okay, where is that error? Okay, anyway, are we clear with this coupling?
Yes, sir.
Yes, sir.
Yes,
So
sir.
if you guys have a
Yes, sir.
question, just let me know. Okay. Anyway, so this one is the node direct coupling from M1 to M2. So that is one thing that you guys need to check, not the M11 and M12 connected to M1. Okay, and then this one is data coupling, wherein you're using, yes, it's very obvious, you're using the data variable of the module 11 and then module 12 uh, uh, for you to be able to make this module 1 work. Okay, call it one data coupling. And then we have this is stamp coupling, wherein two modules are stamp coupled if they communicate using composite data items such as structure. So in here, this one is data coupling. Just put another, that's actually similar with this one. Okay, because one stamp coupling. If you need the data and then need this one or this module will verify the data before sending back to this one. Okay, then got one stamp coupling. The next one is control coupling. Control coupling exists among two modules if data from one module is used to direct the structure of instruction execution in another. So this one is also similar uh, with this one. Okay, it's just that you can see that it's now a, let's say, 3 lines. Okay, so two will enter and then one will go back. So we call that one control coupling. Or we could say that that's also stamp couplings. Just that this one is using more components, more objects, more data, or more variables. Okay, then that's the only time that we could say that it's a control coupling. So it's a direct structure of instruction execution into another module. Okay, so 2 lines only, going in, going out, and then in here it's 3 lines away. Okay, then we also have external coupling, horizon, when two modules share an externally imposed data format, like for example this one. Okay, so before in control coupling, so it's one module to another module only, but in here in external coupling, you're now using two module. Okay, at the same time it's highly tight. Okay, highly tight, highly coupled, or tightly coupled. Then that's the time that we could see that it's now external coupling. Okay, so two modules is now highly coupled with this module. Okay, and then we have common coupling. So two modules are common coupled if they share information through some global data items. Okay, I guess it's similar with this one, but just more data being shared together, being used together. Okay, and then the last one is content coupling. So this one now is you're now getting the data from one exact module. Okay, you're now using the entire content of that module. Okay, so it's now integrating the entire module, not just using some part of it, but using the entire module. Okay, to combine as one module. Okay, so I hope we're clear with these different types of coupling. So any questions so far? from no coupling to content coupling?
Wala naman po, sir.
None, sir.
How many minutes more do we have? 12 minutes. Okay. So I hope we can finish 4 or 5 more slides. Anyway, so let's now move to cohesion. So coupling is now like connecting from one module to another module, while module cohesion is working internally, okay, in its own module only. Okay, so this one right here you're seeing is one module only, which composes different parts of it. See, we have 1, 2, 3, 4, 5, 6. Let's say we have 6 features, or let's say we have 6 functionalities under this one module, and then this cohesion right here is trying to identify if is it really needed, or is this function really needed for you to make this module work on its own. Okay, it's like testing. Okay, it's a module sprint. Okay, so that's how cohesion work in terms of uh, modularity. Okay, so coupling is connecting or how they connect with each other. Cohesion is how the functions work in that specific module. Okay. Anyway, so we have here the types of module cohesion. So we have the functional, so it could be again function, could be sequential, could be communication, could be procedural, could be temporal, could be algorithm or logical, could be coincidental cohesion. So we also have here from best to worst. Okay, so if you're only using functional cohesion, then I think that's really the best uh, way in creating a certain module. But if you're using, let's say, sequential, communication, procedural, up to the coincidental cohesion, then that is not a good idea anymore. So in other words, the more that your say functions, the more that we are really relying with each other, the worse it is. Okay, so the lesser the cohesion, or the more you stand alone your feature, your functionalities are, then the better. Okay, because with that you'll be able to have lesser errors, easier way to solve things. Okay, and then yeah, it's more simpler uh, if you're going to do that one. Okay, in other words, it's not that complex. All right. Anyway, so functional cohesion, I guess this is very straightforward. The set exists if different elements of a module cooperate to achieve a single function. So 2 function will be needed, or 3 function will be needed to come up with this module. Then we also have sequential cohesion. So a module is said to possess sequential cohesion if the element of a module forms the components of the sequence, where the output from one component of the sequence is the input the next one. Okay, so this one is a little bit more complicated since you need now the data, okay, from this function, okay, into this another function. Okay, so we call that one sequential cohesion. And then we also have communicational cohesion. So a module is said to have communicational cohesion if all tasks of the module refer to or update the same data structure. So for example, the set of functions defined on an array or a stack. So before, it's this using maybe function to function, and then into, let's say, from input to fetching this data to another function. But if you're using an array, or let's say a stack, then we call that one now a communicational cohesion. Okay, and then if you're using now algorithm, okay, decoding a message or transcribing a message, then we call that one now procedural cohesion. Okay, and then if you're using there's no example, but anyway, Temporal Fission is when a module includes functions that are associated by the fact that all the methods must be executed in the same time. The module is said to exhibit temporal cohesion. So before it's this simultaneously from module, I mean from function to function, okay? So it has this flow. But if there is now two functions that needs to be executed at the same time, then we call that one now temporal cohesion or cohesion, okay? And then logical cohesion is a module said to be logically cohesive if all the elements of the module perform a similar operation. Okay, for example, error handling, data input, and then data output. Okay, so let's see, each of your function now is needs to be validated, needs to be sending a data, needs to be giving an output. Then we call that one now logical cohesion. Actually, this part already is super complicated already. It's really dependent on each of your functionalities or objects or data in that specific module. Okay. And then the last one is coincidental cohesion, wherein a module is said to have coincidental cohesion if it performs a set of tasks that are associated with each other very loosely or not at all. Okay, wherein let's just see that this one is already complicated, right? So one is more complicated, wherein everything now, every task or performs, I mean instruction, okay, or inputs or outputs are now being used at the same time, and then, or if not, being processed at the same time, okay, or will execute at the same time. So that one is coincidental cohesion. Okay, we have error handling and so on and so forth. Anyway, so yeah, those are the different types of module cohesion. So are we clear? Any questions so far?
Yes, sir.
Answer.
None, sir.
All right, so we still have 5 minutes left. So I guess we can still finish 2 more slides, maybe. All right, anyway, so here are the differences between coupling and cohesion. So coupling is called intermodule binding, where we're going to connect two modules, while cohesion is called intra-module binding, wherein intra is only dealing on uh, one module or on its own module, and how your internals work with each other. Then coupling shows the relationship between modules, so it's very straightforward. Cohesion shows the relationship within the module. Okay, so this one shows how does your functions work with each other. How does your sequential, logical, or communication or procedural work with each other, okay, in that one module only. And coupling shows the relative independence between the module. Okay, yes. And cohesion shows the module's relative functional strength. Okay, so yeah, the lesser they are connected with each other, the better. Okay, the more that they are working with each other, then the more complex it is, the more worse your cohesion is. Okay, and then while creating, you should aim for low coupling. Okay, dependency among modules should be less. Well, we already discussed this one a while ago. While creating, you should aim for a high cohesion. Wait a minute, why is it separate one or a different? I mean, it's the opposite of what we're learning here, because from best to worst is just a single function. And then the logical cohesion wherein you now have error handling, data input, and data output. But in here, it is now saying that while creating, you should aim for high cohesion. For example, P as a component or module focuses on a single function, single-mindedness with little interaction with other modules of the system. I see. This one right here is the highest cohesion, okay? And this one right here is the lowest cohesion. So highest is the, feels like it's really weird because when we say cohesion, the more that they are intact with each other, right? It's like the word cohesive. You guys are going to search for the meaning of cohesion, the action or fact of forming a united whole, right? So the more cohesive it is, the more cohesion it is, the more that they are intact with each other, the more that they are working with each other. Am I right? Do you guys get what I mean? Hello,
Yes, sir.
hello. So this one is quite ambiguous, right? This one is quite incorrect in the sense that it says here that function to function. Well, actually, it explains here that single-mindedness with little interaction is actually high cohesion, okay? Which is quite weird. Anyway, well, let's just follow this one. But if it's me, I will see low cohesion because it's the lesser that they are working with each other, the more that it's single, or it's really talking about the unity or the, as a whole once it's connected as one. Well, either way, okay. So you must have a lesser or little interaction only, okay, with other modules of the system. So yeah. Then in coupling, modules are linked to the other modules. Well, it's obvious. And in cohesion, the module focuses on a single thing only. All right. So are we clear so far with the difference between coupling
Yes,
and
sir. Clear naman po.
okay, so we don't have enough time